What's up, guys? We're going to be solving some simultaneous equations today. The reason I thought I'd do this was because when I remember being in high school and finding simultaneous equations incredibly difficult. And the truth is, they're actually quite straightforward once you actually get into it and once you practice. The key is to practice with maths and maybe a few sciences. When it comes to the application, it's always about practicing. Memory will only take you so far. So I'd say with things like simultaneous equations, practice is key. Okay, let's get into this. Okay, so solve the simultaneous equations. 3x plus 4y is 7 and 4x plus 4y is 8. This is a nice and easy one just to get started. See how it's done. Okay, let's start. So already I know that the y terms, I want to cancel them out, so I'm just left with x terms. You always want to cancel out one of the variables. So I'm going to cancel the y terms out, and because they're both 4y, I can just subtract one from the other. I'll subtract the 4x plus 4y is 8 from the 3x plus 4y is 7, because it'll give me better numbers. It'll give me positive numbers. Okay, so 4x plus 4y is 8. And when you're doing your x's, do them like curly like that, and it'll just differentiate from like a multiplication sign. And then we're going to subtract that from 3x plus 4y, which is equal to 7. What you'll get is 4x minus 3x is just x, plus 4y minus 4y is just 0, is equal to 1. So therefore, we know that x is 1. Once you've found out one of the variables, whether it be x or y, simply substitute that into one of the original equations and you'll find out the other variable. So I'll sub in x is 1 into the first equation, 3x plus 4y is 7. So I'll get 3, 1, which is x, plus 4y equals 7. So 3 times 1 is 3, and then I'm going to subtract this 3 from both sides of the equation, and I'll get 4y equals 7 minus 3, which is 4. Now I know that now I need to divide the 4y by 4 and this by 4. So divide both sides by 4 and you'll get y equals 1. So we now know that x is 1 and y is 1. It's pretty straightforward. It's just once you start practicing these things, it gets a lot easier. I actually don't use simultaneous equations as much anymore. I prefer to essentially find one of the equations in terms of one of the variables. So find an equation in terms of x or an equation in terms of y, and then sub that in to the other equation. I'll show you at the end. It's a bit trickier, so if you prefer simultaneous equations, definitely use simultaneous equations. Okay, so this is our second example. Solve the simultaneous equations. 2x plus 5y is 19 and 3x plus y is 9. Now the beauty of maths is you'll get one sort of method of how to work everything out in that particular topic, and the values will just change. So as long as you know how to use the method and as long as you practice well enough, you should always be able to answer the questions successfully. With this question, the numbers are a bit dodgier. You don't have an equal sort of variable in both. You don't have like a 3y and a 3y. You've got a 2x and a 3x and a 5y and a y. Now immediately I'm thinking I should probably cancel out the y's because I've got a 5y and a y. If I times the second equation by 5, times all of it by 5, I'll get a 5y in there. I'll get two equal variables in the 5y's that I can then cancel out. So that's what I'm going to do. So times 3x plus y is 9, all by 5. So do that to start with. I don't want to work in black. Which is blue. And try that again. Alright, so 3x plus y equals 9. Times that all by 5. You'll get 15x plus 5y equals 45, I believe. Pen looks slightly shorter than last time, doesn't it? Alright. Yeah, so now we've got a 5y and a 5y. So what I'll do is with this equation, this new equation, I'll subtract it from the 2x plus 5y equals 19. And remember, when you multiply by 5, you have to multiply both sides of the equation, otherwise it won't balance out. Okay, so 2x plus 5y equals 19. And I'm subtracting because there's two positives and I want to get rid of it, so I'll subtract. So 15 minus 2 is 13. The 5 minus the 5, it will cancel, give 0. So I'm just left with 13x equals 45 minus 19, which is 26, which is good because that means x equals 2. Yeah. So now that I know one of the variables, I'll substitute that into the original equation to get my second variable, to get my y. So I know that 2x, which is 2, plus 5y equals 19. 2 times 2 is 4, so I get 4 plus 5y is 19. Subtract 4 from both sides of the equation, and you'll get 5y is 15. And then divide 5 by both sides of the equation to isolate the y. You'll get y equals 3. Simple as that. X is 2, y is 3. As long as you practice, it's straightforward. I'll do the exact same equation example, and this time instead of doing simultaneous equations, I'll do the substitution method that I was talking about at the beginning. It is a bit more tricky and it can be a bit dodgy when there's big numbers involved, so it's not something I always use, but it can be easier for me sometimes. I don't know, it depends on the person, I guess. Anyway, I'll do that now. Okay, so what I'm going to do is, because I know that the 3x plus y is 9, the second equation, I can, without having to divide or anything, I know that I can make that equation in terms of y by subtracting the 3x from both sides. So I'll show you. So subtracting the 3x will give me y equals 9 minus 3x. So now I've got it in terms of y. Now because it's in terms of y, it means I can substitute it into the first equation where the y is. So I'll get 2x plus 5y. But I already know that y is equal to this 9 minus 3x. So I'm going to put in brackets 9 minus 3x, and it has to be in brackets because this 5 here, you have to times it by every single variable that's equal to the y. And then that's equal to 9, isn't it? No, it's equal to 19, sorry. Okay, so then it's simply just expand out the bracket, so you'll get 45 minus 15x is equal to 19. And I'll get 45, and I'll collect the x terms. So I've got a 2x and I've got a minus 15x. It'll give me a minus 13x. That's equal to 19. And now what I'll do here is I'll add on the 13x to both sides, because I want the 13x to be positive. I don't like it negative. And I'll subtract the 19 from both sides also. And I'll do that all in one step. So I'm adding on the 13x to the other side, and I'm subtracting this 19 from both sides as well. So I'll get 45 minus 19, which is 26, I believe, equal to, adding the 13x on, it will be equal to 13x. And then simply divide both sides by 13 to isolate the x, and you'll get x equal to 2. And then it's the same as before, but now because we've got this equation here, y is 9 minus 3x. I know x is 2, so y is 9 minus 3, x is 2, so it's that. Now I know that 3 times 2 is 6, so 9 minus 6, which is 3. And that's exactly what we got last time using the simultaneous equations method. It can be a bit more tricky, especially when you've got harder numbers. Like for example, if I was to use a 2x plus 5y is 19, and I was to rearrange it so it was in terms of y or in terms of x, it would be a lot more trickier because there's a 5y and a 2x, and it would lead to fractions, and you just don't want to deal with fractions. Avoid fractions wherever possible, really. But if you got something here like a y, or you've got an x, it can be a better method if you prefer it, but use whichever method you feel comfortable with. And with a bit more practice, you literally get simultaneous equations easily. It's an easy thing, it just requires practice. But yeah, thank you for watching. I'll see you next time.